So now we're going to use the slope of the secant line to help us solve for the slope of a tangent, or the slope at a given point. So again, as a reminder, slope of the secant line is change of y over change of x. We can rewrite that as f of x2 minus f of x1 divided by x2 minus x1. We can then rewrite that in the term of f of x1 plus delta x minus f of x1 all over delta x. And our goal is to have delta x go to 0. But in order to do that, we're going to need to think of the limit. So let's look at an example of how we would do this. Let's let f of x equal 3x squared. All right, so now we're going to apply this equation right here to f of x equals 3x squared. So we want to think of, let's take the limit as delta x goes to 0, because that'll tell us the slope of the tangent line of the secant, which is equal to 3 x1 plus delta x squared. So we take the x1 plus delta x and just put that in for 3. So that's how we get 3 times x1 plus delta x squared minus 3 times x1 squared, which is f of x1, divided by delta x. And we want to take this when the limit goes to 0. Now we can't put 0 in now because we will divide by 0, and that is against Doc Brown's philosophy in Back to the Future, both 1, 2, and 3. So we need to think of a way to deal with this numerator such that we can cancel something out with the denominator. So we notice that this is a square term, so let's go ahead and FOIL that out. So step 1 is to FOIL. So to FOIL that out, I get 3 times x1 squared plus x1 delta x plus delta x x1 plus delta x squared minus 3 times x1 squared, all divided by delta x. So step 1 is FOIL. Step 2 is to collect and cancel. So one thing you'll see is we can collect x1 delta x x1, and call this 2 x1 delta x. Okay, but we can multiply this 3 through, so we'll have 3x1 times 6 x1 delta x plus 3 delta x squared minus 3x1 squared. Well, we have positive 3x1 squared here minus 3x1 squared there. So that term cancels with that term. So after collecting and cancel, we get 6 x1 delta x plus 3 delta x squared all over delta x. Step 3 is factor out and cancel. So you notice we have a delta x here and two delta x's there. So let's just pull one out. So if we pull one out, we'll get 6x1 plus 3 delta x times delta x, all divided by delta x. And now what's nice is this delta x cancels with that delta x. And now we've solved our problem. Remember, our original problem is that we want the limit of delta x to go to 0, but we can't because it's in the denominator. Now it's not in the denominator. So step 4, take the limit. So remember, our limit is when delta x goes to 0. So here we're going to take the limit as delta x goes to 0. So everywhere we see a delta x, we can put in 0. It's not in the denominator, so it's not going to ruin Back to the Future. So now we'll get 6x1 plus 3 delta x. Well, delta x goes to 0, so now we're left with step 5, which is our final answer. And that is the slope of the tangent is equal to 6x. Now we had 6x1, but we didn't tell you what x1 is, so it could be any x. So the slope of the tangent line is 6x. And so what does that mean? Well, let's look at that briefly. All right, so let's go over here on a new piece of paper and draw out what this graph looks like. So this is f of x is equal to 3x squared. And we said that the tangent line, slope of the tangent, is equal to 6x. So that tells us, let's just choose a point. Let's choose the point that x equals 2. So the slope of the tangent line says is the slope where it touches this line only once. This slope is equal to 6 times 2, because x is 2, therefore this is 12. Well, what about the slope right here, when x is equal to -1? So the slope that touches, actually, by the way, of that line is equal to 6 times -1, or -6. So you see it's a negative slope. So this slope of the tangent line tells us any x we put in, we can find the slope at that given point of our original function of f of x equals 3x squared.